Okay, number 1 from your sheet. A satellite orbits Earth at a distance of 1.28 times 10 to the 7th meters from the center. So that's the r, radius of orbit of the satellite. 1.28 times 10 to the 7th meters. The satellite weighs 6,000 newtons on the surface of the Earth. So that's the Fg on the surface of the Earth. And from that we can find the m, because we can just divide it by 9.81. And so when we do, we get 6,000 divided by 9.81 meters per second squared. So the mass of the satellite is 611.62 kilograms. And actually, I think that's part A. Okay, so you can use 9.81 there because it says on the surface of the Earth. For the satellite in orbit, calculate its mass. So we did that. Calculate its weight in orbit. So its weight in orbit is Fg, but in orbit we can't use mg. We have to use g, m of the Earth, m of the satellite, over r squared. So Fg will equal 6.673 to the negative 11 Newton meters squared per kilogram squared. Mass of the Earth, 5.98 to the 24th kilograms. And the mass of the satellite you just found, 611.62 kilograms. And they gave us the R, 1.28 times 10 to the 7th meters. And remember, that's squared. And when you do this, you should get 1,400, I can't see, 89.65 newtons. Part B. Part C says find its speed. So you have a couple possibilities for speed, right? If you go back to this equation, you could do V equals 2 pi r over t, or V squared equals g, mass of the central body, over r. Well, the problem with using 2 pi r over t is you don't have t. So I'd go with g, mass of the central body, over r. So V squared is equal to g, mass of the Earth, over r. So 6.673 to the negative 11 Newton meters squared per kilogram squared times 5.98 to the 24th kilograms, and the r was 1.28 to the 7th meters. And remember, that's going to be V squared. And I think before you take the square root, you get something like 3 I lost it. No, 3.1175. 175 times 10 to the 7th. And that'll be meters squared per second squared. Take the square root and get 5583.5 meters per second. Okay, so there's number 1. Number 2, a satellite which weighs again. Okay, so a satellite which weighs Fg 1 times 10 to the 4th newtons on the surface of the Earth. So again, we can get our m by taking our 1 times 10 to the 4th newtons and dividing by 9.81. And you should get a mass of 1,019.37 kilograms. Okay, so that's the mass of our satellite. So a satellite which weighs 1 to the 4th newtons on the surface of the Earth is put into circular orbit 7.05 times 10 to the 8th meters above the Earth's surface. So that's our height. It's giving us our height. It's saying this height is 7.05 times 10 to the 8th meters. And so to get our radius, you need to add that to our radius of the Earth, 6.38 times 10 to the 6 meters. Okay? And so when you do this, the radius of the satellite should end up being 7.1138 times 10 to the 8th meters. All right. So then the question wants us to find its mass. We just did right here. Its weight. So again, Fg is equal to G, mass of the Earth. It is over the Earth, right? Yeah. Mass of the satellite over R squared. So 6.673 to the negative 11 Newton meters squared per kilogram squared. Mass of the Earth, 5.98 times 10 to the 24th kilograms. And then mass of our satellite, 1,019.37 kilograms. And then over the R we just found up there. Oops, maybe a little bit too big. 7.1138 times 10 to the 8th meters squared. Okay, and when you do this, you get an Fg of 0.8038 newtons. Okay, part C says find its velocity. So again, I would probably use v squared is equal to g mass of the Earth over r, because we have those things. So 6.673 negative 11 Newton meters squared per kilogram squared, 5.98 to the 24th kilograms over 7.1138 times 10 to the 8th meters. Remember, that's going to be v squared. So, and when you get it, it's 560,945.4862 meters squared per second squared. Take the square root and you get a v of 748.963 meters per second. All right, that's the v. And then it asks for centripetal acceleration. So AC is equal to v squared over r. So take your 748.963 meters per second, that's in your calculator, square it and divide it by the 7.1138 times 10 to the 8th meters. And when you do, you should get an AC of 7.885 times 10 to the negative 4 meters per second squared. All right, so that's number 2. Number 3, a satellite orbits Neptune in 200 minutes. So T of the satellite is 200 minutes, which of course we'll have to change to seconds. The radius of its orbit measured from the center of Neptune, so they're giving us R of the satellite, capital R, is 2.92 times 10 to the 7th meters. Calculate the average speed. So this time I would use the v equals 2 pi r over t because they've given us the r and the t. So 2 pi 2.92 to the 7th meters, and the t 200 minutes times 60 seconds should be 1,200 seconds, and you should get a v of 15,289.08 meters per second. Okay, for our speed. And then part B wants us to find the centripetal acceleration. So then it's just going to be AC equals v squared over r. So your 15,289.08 meters per second squared over 2.92 times 10 to the 7th meters. And you should get an AC of 8.005 meters per second squared. Number 3, we're going to run out of time on number 4, which says, what orbital speed must a satellite whose mass is 800 kilograms have in order to maintain an orbit that is 2 times 10 to the 7th meters above Jupiter, so that's the height of the orbit, where the gravity